So previously we assigned a constant velocity for this input link, but you may want to assign a more complex velocity into the system and to run a simulation. So in order to assign a more complex velocity, we need to go back to reset the velocity. So right now, because you finished this setting, there are two modes when you are in this dynamic analysis. One mode is called the play mode. I name it in this way. It's not named in this software, but I call it play mode. So play mode is basically play the simulation. Once you finish a simulation, so it's like playing a video. So you click this one, you will run a video, and like forever you can click the loop, and you will just like run forever. And another mode is what we have done previously. It's a construction mode. Construction mode is to allow you to modify some variables, such as the input velocity. So we need to switch from this play mode into the construction mode in order to modify those input. So in order to enter the construction mode, you move your mouse here and click this one. Then you will move back to the construction mode. So, sorry, let me go back to the play mode. In play mode, if you want to modify the revolution, the angular velocity, you move to this revolute joint and click property. You will find you cannot modify the values. Yeah, they are not selectable. So you need to cancel them. You need to switch to construction mode. Click this one. So again, go back to this one. So right now we are in the construction mode. And go to property. Then right now the value are editable. You can rewrite those values. And let's set a more different input. So previously we used a constant value, but this time we are going to use an input grapher. So when you choose an input grapher, there will be an icon shown here. You click this icon, there will be a graph shown here. So here you can set your velocity. So for example, you can see there's a starting point and there's an end point. At the starting point, the velocity is 0. At the end point, velocity is also 0. But you can change this. And there are options here. You can use a linear ramp. You can use cubic ramp. Then let's just see what's the difference. You can just drag this one, or you can also type. You can also type here. Yeah, okay. So I type here, if you use a linear ramp, then the rotational speed will start from 0 at 0 seconds, but it will increase to maybe I say 100 at 3 seconds. So you will gradually increase the angular velocity, and you can use maybe you can use a cubic ramp to do so. So you use a cubic line to connect these 2 points, or you can use a sine wave. I don't know. You can use whatever you prefer. So I think sine wave you need to determine the amplitude and the frequency, etc. 120 is maybe 1 Hertz, no phase. Yeah, so the input will be in this form, or this just up to your choice. You have many different choices to input. You can also load curve, but I haven't used this one before. But so if you want to use a very complicated curve, and that's not included here, you probably need to look into it. Look into the tutorial of inventors. But anyway, we just introduced there are some other options instead of using a constant input velocity. So let's try this sine wave and to see how it works. So okay, I click OK and run. When you click this one, you will run the simulation. So okay, there's a sine wave, so it's swinging. That's it. Once finished, then you can again go to the output grapher to see those curves. Assembly, standard, and to see this planar joint P3. So that's the motion of this blue slider. You can also see this P2, P1, they are still 0 because there's no motion in that direction.